In this excerpt from the Ben and Ryan show, Justin Scott reviews his process for updating stored password hashes when you want to move to a more secure algorithm.
All right, so let me ask you this question now. You talked about migrating encryption keys, that if someone had a weak encryption key, they could unencrypt the data and then re-encrypt it with a stronger key or a stronger algorithm. In that case, the person storing the data also stores all of the relevant pieces of information that they need to do this. If someone's listening to this episode and they're thinking to themselves, oh, I have passwords that have been stored at a weak hash or a weak algorithm, and I need to migrate those to a stronger bcrypt or scrypt or argon2 ID, they might think to themselves, but I can't do that because I don't actually have the user's password. But that's not the case, right? There are ways to migrate password hashing algorithms even without the password. Is that correct?
So there's a couple of different ways that people can approach this. The one that I would recommend is implementing code anywhere that a password is getting set. So, sign up routines, password resets, if you have password reset built into your backend applications for management, would be to have some sort of a version check at that point, whether it's a separate database field or if you're just looking at the properties of the data. So for example, an MD5 hash has a fixed length and it always looks the same and it has the same kind of characters in it. Mm-hmm. So if you're on an application that's using MD5 and you want to move it to bcrypt, for example, then when you go to validate the user's password at login, what you're going to do is check the properties of that data or a version field in your database and see, has this password been upgraded yet? If it has, great, validate the bcrypt. If not, then go ahead and generate a new bcrypt hash and put that in the database in place of the MD5 hash. And then over time, as users are logging in, then they're going to have their entries updated to be on the new version. And I've seen some organizations that have even taken that a step farther to say, we're going to set a deadline and we're just not going to support the old authentication method after a certain date. And that could be 30 days out or 60 days out or a year or however long is in their policies. And at that point, then they're going to look at the database and see we've got so many hundreds or thousands of accounts that have not been upgraded. So we're going to send those people an email and say, we're going to start requiring that you change your password and we're upgrading our security and your password's out of date. You need to come to the account. And there's going to be some percentage of users that do that and some percentage that don't. And over time, there's just going to be some users that are deceased, have moved on, no longer use your service, changed email addresses, have gone offline, whatever the case is, that are just never going to get updated. And as a business, you just have to make the decision: do I want to remove those accounts and say, okay, these people have not logged in 5 years, and they're we still have this old password hash, so let's just clear it out and deactivate those accounts. Or what some companies have done is they would take the existing password hash and then rehash it with another hashing algorithm.
So just to clarify, you're saying take the existing MD5 hash in the database and actually run that then through bcrypt.
Right.
Okay.
And so what you end up with is a bcrypted hash of an MD5 hash of a password. And so now when you're validating, you have to take the password, generate an MD5, and then validate that against the bcrypt hash. That's considered less secure.
But you could combine the two, right? You could do that as a fallback. Or so you were just talking about how you could have code that checks the algorithm on the fly as the user's logging in. You could do something like that where I don't know, I'm thinking off the top of my head here. You first try the valid, let's assume that this is the right password, try to do the bcrypt. If that fails, you could then try MD5 hashing the user's password, then running it through bcrypt. And if that works, you could then re-encrypt it using just the bcrypt.
Right. So that would be part of a rolling update scheme, which is the preferred way to do it. Is pick your new algorithm, and anybody who is not using that new algorithm, go ahead and move them into that as they log in. The only downside to that is now you're going to have accounts in your database that have MD5 hashes. You're going to have some that have bcrypt, some that have scrypt, some that have whatever the new hotness is 5 years from now. And you're going to end up with this mismatch data in there. And as developers, we like everything to be nice and neat.
Yeah.
And everybody to be on the current thing. And some of this just goes back to, business risk decisions and risk analysis as to what risk you're willing to accept as an organization. And as long as most of your active users are on the current algorithm, if you've got a few people that haven't logged in 3 years, chances are their password is probably out of date anyway. And so if their hashes got leaked and cracked, probably not going to be a big deal because their accounts elsewhere are probably not using that password anymore anyway. But again, it's all just risk analysis as a company.
But there's always a path forward, which is a great takeaway. Anyone who's listening to this and they feel like there is a weakness in the way that they've done something, it's just address it. Like, it's not a lost cause. You can move forward and become more secure.
Yeah, absolutely. And like I mentioned, I think earlier in our conversation here, like I still find applications that I work on where they're just using a basic non-iterated MD5 hash for data integrity, and as we find them, we move them into a more modern standard. This stuff is we acquire applications from other companies, and sometimes that have old technology built in, and we just look at it and go, "Yep, that's quaint. Let's move it forward to the new version," and we move on.
Very cool.
Yeah, that's interesting. The passwords, I hadn't thought of the fact that you can't actually decrypt it. It's not. So there is no way to re-encrypt it to the new algorithm because you can't decrypt it. You're just comparing hashes.
Right. Yep.
Until they log in, and then you actually have their password in memory at the moment.
Yes. those few milliseconds while you've got it, that's the time to work with that data and move it forward to the new version. A lot of businesses don't want to do that. Send that email out to the users and go, "Hey, we need you to reset your password and log in," because it gives people the impression that there's been a breach of some kind. Yeah. They just don't even want to plant that seed with users. Yeah. And so they just will do that rolling upgrade in the background and not even mention it. And that's fine.